Foresight Fight devlog number 40, or maybe I should say Audiolab devlog number 3. So yeah, still focusing on audio. My mission right now has been to synthesize new instrument samples for use with this, instead of just like this stuff. Why are these buttons misaligned? How did I manage that? This is off by 1 pixel. That's weird. Anyway, yeah, I can export audio for these if I want. No, but that doesn't really have any bearing on what I've been working on. So, right, this screen, everything I showed last time with all this synthesis. Where is my instrument view? That's completely missing. Oh, I know what's wrong. Okay, I actually broke my my thing there. That was supposed to display the. All right, I'll explain why that is in a moment. Didn't realize until now, but it doesn't actually matter for what we're doing today. So, right. I have a few little test songs in here. The C major scale, this little song, the other one, all being played with an SFXer pulse wave synth. Pulse wave is the general term for square wave when duty can be involved. It's something like I forget what I used for that. Anyway. So it's all being played with an SFXer synth, and I was not entirely happy with that. It did the job to get me this far, but not much farther. So, I want to be able to write compositions with a variety of instruments that sound different, of course, and I want to make them in some way other than with these two synthesizers that I've ported over. You know, BFXer is just SFXer plus a few extra parameters. And I also don't want to rely on recorded samples. I do want to generate them from waveform math. So where that leads me is implementing my own synthesizer using what I learned from porting these two over to my own code, which was quite a bit. I got a pretty good grasp on how they work and what I would do to write my own. So I've been working on a whole new thingy here. So this is a new screen in my audio lab. This almost didn't happen today. I thought I was going to wait an extra week just to have something a little better to show, but I kind of pulled it together at the last minute, and it's you know, I can show where I am and feel kind of okay with where I am right now. So this screen is like super unfinished. There's nothing here that's supposed to be something. There's nothing here that's supposed to be something. So basically, like, it took a while to arrive at this structure, but what I have is a synthesizer skeleton that works based on 3 basic curves. So there's a wave shape. Let's start with a more familiar one. Here's a sine wave. There's a wave shape that determines like the basic form that the sound takes. Then the frequency curve, which determines how often that repeats and how that changes. And there's an amplitude envelope, which decides the amplitude. So it's just like the, here we have attack, sustain, decay, punch, those things. So amplitude envelope controls this, but works on an arbitrary curve function that can take any shape. So, I could have something be real loud at first, then go quiet, then get a little louder, then go more quiet, or just, any arbitrary shape that I want. I have the capability to plug that into a synthesizer here. So, this is just a sine wave, nothing too exciting. Frequency curve, same thing for frequency. So I can set the, let's see, if I go back to SFXer, so this would be the equivalent of, let's put this back to normal. That's pretty quiet. I can turn it up a little bit. So this would be the equivalent of, like, for example, set the bass frequency, have the ramp do stuff. But I can do things much more extensive than just, like, ramp up and down and 1 extra parameter for changing how it ramps over time. Yeah, just any arbitrary function that returns a floating point value that says what the frequency is at each frame of sound. So I have very fine control over that. It's all, the only way to control it right now is to write different code, like to actually write a function of let's see what I have here. So there's like somewhere in one of these, it's actually in sequencer screen for some reason. Have a bunch of test stuff here. Right, this is for wave shape. Oh, I'll talk about this in a minute. This was something. But yeah, so here would be a frequency function that I was using that kind of oscillates up and down and is a whole lot of fun. Let's recompile with that and hear it just for fun. Yeah, this is, again, this barely happened today. The UI just isn't there. UI is complicated. That was probably more than half of my work in terms of time spent on this. Let's see, I have this button that's overlapped by the waveform view. Don't worry about it. But anyway, so I have this like oscillating synthesizer there, and if I change the function to just return to 20, which is actually the frequency of A4. I don't know, I'm finding different, I think there's different notation for like which octave is which. 220 is an A note at some octave. 440 is one octave up from there. Whether you call that 3 or 4 or 5 or whatever, I don't know. Different sources said different things. So that's the exact same wave shape function, which is actually this one. Again, I'll talk about this in a minute. With a different frequency curve. So the only thing I changed between those compilations was what this function returned, and this is the one used for the frequency curve there. And when I was doing that, yeah, so here I have an amplitude envelope that just starts at whatever that value is for however long that duration is, then linearly ramps down to 0. So that's the basis of how this is built. So I was doing that on the sequencer screen here, just trying to encode here with writing out math functions, trying to see what kind of sounds I could create. This here was my attempt to reverse engineer a recording of a piano key and sort of see like what frequencies it was built from, and then build a curve out of that and see what it would sound like. So my observation was that there were frequency responses at like every half step of phase multiplier getting quieter and quieter as they get higher than the base frequency. Why is this? Oh, I see. So this is actually, I could write it like this, and that would all line up. I could also write it like something like that. Anyway, yeah, so that's the actual frequency with the strongest response, half of the amplitude, then a fourth of the amplitude for half a multiplier down, this much of the amplitude for half a multiplier up, a full multiplier up. Anyway, so this is just my attempt to construct something and see what it would sound like just as an experiment. And what I ended up with does kind of sound like electric piano samples that I've used in music composition programs before. Then I figured out that BFXer has this thing called overtones, which is essentially what I was implementing there. Let's get this short. So if I put on, where's the overtones? Harmonics, that's what it calls it, same thing. So that has added, let me see, can I zoom in a little more in this? That's added a second sine wave at I think twice the frequency of the basic one. Then if I move the slider again, it adds another one. So essentially what I was implementing was that, just like the particular spacing of what I chose decided the sound of the waveform. So anyway, that was super fun, trying to reverse engineer like what an actual musical instrument does with its frequencies, and work out how I would use that to build my own mathematically. So I know kind of how to do a piano. That doesn't sound much like a piano right now. What frequency am I playing that at? 220, right. A3, A4, whatever you want to call it. So I just thought about this like, okay, so wave shape is super interesting. I certainly want overtones, harmonics, whatever you want to call them, but I want to do a little more than that. So I came up with a little thing. I thought it would be fun, in addition to just being able to choose the basic, familiar shapes that SFXer and friends can do. I thought it might be fun to be able to edit like a Bezier spline and just change the shape of the wave arbitrarily. Let's see what that sounds like. Okay, so it's like a sine wave a little differently. And then I thought it was a little annoying to have to keep like pressing the button to play this. So I did this thing where I can continuously play. Again, let's start with a sine wave, something nice and familiar. I can continuously play this shape while editing it, and that is a fun little toy. So this is making a sine wave right now. I can make it a little quieter to be less annoying, or louder if I really want to hone in on something. I can mess with the frequency. This is a nice little toy here. Sometimes I come here just to play with this, just because it's fun. It's pretty entertaining. And then I have this button where that'll make this snap to piano keys and tell me which one it is. So this is A4. I'm calling it 4. Some people call it 3. I don't know. Music terminology is weird. C5. Wait, really? Why didn't that sound right? Hang on, which one's middle C? C4? Okay, that sounds right. Why does something sound weird to me? No, that's right. It's just because it's just a sine wave. It doesn't sound like a piano key. And I could turn off the snap and just go to whatever exact frequency the slider is at. So non-musical, musical. So that's a whole lot of fun. This is going to get loud if I leave this up. So let's put this back to, I don't know, some decent value. So there's the pulse wave. Yeah, that's real loud. I can mess with the duty on this. And I can see exactly how the wave shape is changing in real time, both here and up there. And I can go both ways with the duty if I want to. Sawtooth, that's familiar. This one doesn't have any extra parameters. Triangle's pretty similar to sine. There's that little bit of interruption as I change those. I should do something to get rid of that, just so I can exactly smoothly switch between these. I could make that happen. I just haven't actually done it yet. So then here's the other fun one. So I wanted to play with a spline editor here. This is kind of jank and not really friendly, but I thought it'd be interesting to see. Oops, okay, I'm moving the wrong control point there. I'm going to put this here. So if I want to, I can turn this into, some kind of sawtooth-like thing by moving these around. Boy, this is an unpleasant sound. So the yellow line shows the Bezier curve. There's a separate line there's supposed to be. Where's the other part of that line? There it is. Oh, if this is far enough left, that just doesn't even draw. Okay, I had to fix that. Okay, I should also be able to toggle off the yellow. Well, you can see the shape that I'm actually making down there. And since I can't do a backward curve in a sine wave, it's just gonna turn this into a cliff, basically. Yeah, so due to the way I'm moving these around, I can make various things happen. Anyway, so this didn't turn out to be as interesting as I thought it would be. I can insert another control point and do fun things here. So, again, this is kind of a fun little toy, but not really, like, all that useful for actually building something that sounds nice. Well, this is actually going out of range, which, it can do. Anyway, let's stop that. So yeah, I built some fun toys here. I think it's going to be more useful to put some kind of system in here where I layer on harmonics, overtones, whatever, basically like have, this sine wave at that frequency and be able to say, okay, so for this wave shape, I also want a sine wave that's half a multiplier above this, a whole multiplier above it at that amplitude. So yeah, building it for math instead of just dragging control points around is probably going to make more sense. I don't know exactly where I'm going with this. This is an explorative process, but, you know, I'm making fun things. Still just fun to play with this little toy. Anyway, so I would have more done here, but I went on a bunch of little side adventures that I'm not 100% happy about. That this is just how software development goes sometimes, especially when I'm writing all my own code for like literally everything here. Sometimes I have to fix basic things, so I had to do a big renderer refactor in order to be able to do to draw this. Drawing this spline view was I'm on the wrong control point. That's the problem. Got it. So drawing these lines, short version of the story is that when I submit draw commands to OpenGL or my GPU through whatever graphics API I'm using, I use separate function calls whether I'm drawing textured filled shapes, like, well, triangles are the basic unit, but, you know, like this would be made of two triangles, one like that and one like this, and in this sort of green color. And I have to make a whole separate function call and set up and everything if I want to draw lines like this. So GL lines mode and GL triangles mode is a different thing. And my renderer was not set up to be friendly to that for the UI framework that I'm using. Foresight Fight uses the same thing, but, you know, like this is a UI text field. This is actually an effect parameter slider, but that inherits from UI slider. Anyway, yeah. So basically those are objects I can instantiate, which, you know, the slider knows its minimum value, its maximum value, the callback to call when I move it around, which in this case is telling my thing to resynthesize and redraw the waveform and also change the value of the text field. Text field kind of talks to the same callback and moves the slider. So anyway, right, so I have this extensive code framework for, I mean, you've seen code that uses this stuff before. I've shown it plenty of times. So I just like instantiate a new UI radio button in the group that includes all of these. Have whatever callback on it, set as parameters. Oh, this sawtooth goes up sharply and then ramps down. That's the opposite shape as mine. Does that really make a difference in the sound? I wonder. It feels like it shouldn't, but it does. Like I once tried taking recorded speech into an audio editor and, you know, flipping it vertically. So, you know, all the ups are downs and all the downs are ups. And surprisingly, it actually changed the sound a lot, because I assume this is like one side of this is physically pushing the speaker element out and one is pulling it in. And it turns out like the polarity of that actually does make a difference, but I don't know how much it would... let's see, if I could exactly land... Let's see, this will be unpleasant unless I turn it down. Oh boy, it's unpleasant anyway. It's hard to land exactly at the same spot, like if I go all the way to the edge. This is just silent. Sounds about the same to me, but maybe it's a little different. It's hard to tell. Anyway, yeah, so just having toys that I can play with things like that is super interesting to me. Having a lot of fun here, and kind of getting toward where I need to be. Let's see, yeah, right, sorry. So renderer refactor, had to be able to draw this in GL lines mode. Before, when I was drawing the waveform, I was doing, actually I think I'm still doing it the same way. I was doing it with quads, like each pixel column is actually its own quad taking up that amount of space, which isn't necessarily efficient, but also isn't necessarily the wrong way to go either. Waveforms are a little weird to draw. But anyway, so that took way more time than it felt like it should. Right, yeah, sorry, UI framework. I was kind of explaining. before my renderer, the way it interacted with my UI framework was to actually take every element on the entire screen, no matter how it's drawn, and collect them all into a single buffer and submit that all in one draw call. So all of this was put together into a list of textured triangles with whatever coordinates and texture stuff and whatever colors with it, and all drawn at once. And that didn't work because if these are all triangles, then I can't draw lines at the same time. So I had to refactor my renderer to be able to actually make separate draw calls per UI element. So, this view that shows the spline control points and everything is in the same logical UI hierarchy as everything else. Now just everything's smart enough to split that off into its own draw call and know, okay, we're drawing lines now. All right, so lines are drawn. If there's anything on top of these, like you can see the slider actually draws on top of the control point there, then it switches back to triangles mode for that. So there was that little adventure. Then there was also a side adventure where, just because I felt like doing it, I picked an item off my to-do list on Foresight Fight to... No, this was because I was testing something and my display went to sleep while I was using my gamepad for an extended amount of time to control the game. So I wanted to be able to say, okay, while this application is active, don't put the display to sleep. System APIs for this were not straightforward. I did not get this done. I still have more work to go on that somehow. It's kind of fun to just watch the shape of that change as I drag these around. It's a neat little toy. Yeah, so still got to figure out how to actually do that. Linux especially doesn't seem to really want to make that an easy thing to do. Other platforms might be a little easier, but got to do it on everything I support. And then there was one more little adventure. I didn't have a pop-up menu in my UI framework. I had radio buttons, I had checkboxes. There's a checkbox. I had sliders, but I did not have a pop-up menu or anything that could serve this purpose. So I went and implemented this thing from scratch. And I wanted it to be full-featured. If this were to be larger than the screen, it would show a little scroll arrow down there, and I could drag down to scroll it. It can be controlled with the gamepad, mouse, everything. Keyboard if I want. It can be controlled with the keyboard. I'm not passing, Audiolab itself is not passing my arrow key presses to this. But the pop-up menu knows how to do it. Anyway, yeah, so these were the adventures of Alex over the last 3 weeks on his journey to getting something done with this. Yeah, so I show an extra window of what would be the edges of this waveform, just so I can know how it lines up in case, I'm messing with a spline and I'm trying to get these to line up and I don't understand like where is the point where this lines up with this, for example. That's why I draw those over there. Yeah, it's still not totally clear. I need a toggle to hide the spline overlay so I can just see the actual waveform. I mean, I can see it down here, but it's not the clearest to know when I've hit that point exactly. But also, this is not super useful. I think this will be much more useful for the amplitude envelope and the frequency curve to have a spline editor for that. Spline editor itself was not that hard to implement. It's actually pretty simple. I already had Bezier evaluation code, and then it was just a matter of like moving a few vectors around logically, mapping mouse drag to move this 2-coordinate vector wherever. And then the rest just kind of works itself out with what I already had. But yeah, like I don't think this is actually super useful for wave shape. It's a fun little toy though. You're very quiet. All right, you're less quiet now. Anyway, yeah, so I made some toys. They'll turn into real tools that actually do useful stuff at some point. So I'm going to keep working away at this, get those instruments reverse engineered so that I can put together some real music that sounds like real music, hopefully. I'll see you next time for that.